Before we get started taking a look at DC to DC converters, let's talk a little bit about the power BJT and the power MOSFET. So unlike the diode, the power BJT and the power MOSFET are fully controllable devices, meaning that whether they're on or off is determined by an external signal that we can provide to it. And so I've gone ahead and drawn the two circuit symbols for the BJT and the MOSFET. And so two of the terminals are going to be connected to the circuitry, and the third terminal is going to be where we provide the control signal to turn the device on or off. So for the case of a BJT, the collector and the emitter of the device are connected to the circuit. So those are the two terminals that are going to be part of the switch. And then the third terminal is called the base, which is what controls the BJT. And for the case of a BJT, the device turns on by applying a current at the base, which I've called here IB. So we can say then that for the BJT, when IB, again the base current, is greater than 0 amps, the device looks like a short circuit. So it's going to be on. So this will be the collector and the emitter. However, when the base current is equal to 0 amps, so IB equals 0, the device is off. So it looks like an open circuit. So there's no connection between the collector and the emitter. Now the MOSFET is similar in the sense that we can provide a control signal to turn the device on or off. But in the case of the MOSFET, it's actually a voltage. So if you see here on the circuit symbol on the right, the drain and the source are the two terminals that are going to be connected to the circuit. And the third terminal is called the gate, which provides the control signal. So for the MOSFET, instead of injecting a current at the control terminal, what we do is we apply a voltage to it, and that determines whether the MOSFET is on or off. So we can say that for the MOSFET, when the voltage VGS, so the voltage from gate to source, is greater than 0 volts, so it's positive, the device looks like a short circuit. So the drain is going to be connected to the source. So these are the other two terminals. And then when VGS is equal to 0 volts, the drain and the source are not connected. So the device looks like an open circuit. So these two devices are very useful for DC to DC converters because they're fully controllable, as opposed to the diode, which was controlled by the voltage and the current in the circuit itself. So for these two devices, we can actually provide a control signal to turn them on or off. And also you can think of the BJT as a current control switch, and you can think of the MOSFET as a voltage control switch. And they can both be used as switches in DC to DC converters, and we're actually going to use them interchangeably in the circuits. But just know that you can use either one. So now that we've looked at the power BJT and the power MOSFET, which we're going to use in DC to DC converter circuits, let's go ahead and take a look at the converters.